Hello and welcome to our second lesson on solving simultaneous equations using a difference bar model. So last lesson we looked at setting up our bar model and looking for the differences, and then we looked at situations where you needed to multiply one of your equations so that you had either the same number of x's and y's so that you could compare and find the difference. So today, as you can see on the screen, we have a pair of equations where it's going to be difficult to multiply to make the same number of x's by just multiplying one equation. And that's also true for y. It's going to be difficult to multiply to make the same number of y's just by multiplying one equation. So what we're going to do here is multiply both equations. So our bar models as they stand at the moment, 2x add 3y is equal to negative 7, and 3x add 2y is equal to negative 8. So what I'm going to do is multiply to get the same number of x's. So I'm going to multiply the first equation by 3 so that I've got 6x. But I've got to multiply everything through my equation. So 3 multiplied by 2x is 6x. 3y multiplied by 3 is 9y. And negative 7 multiplied by 3 as well will give me negative 21. And if I multiply my second equation by 2, then I'm also going to have 6x. So that's my first equation there. And then I'm going to multiply my second equation by 2. So I'm doubling the x's, doubling the y's, and doubling the negative 8. And so I've now got two new equations. Now this is a bit like when you're finding a common denominator with two fractions that both have different denominators. You're looking for the lowest common multiple. So I decided to make my x's the same. The lowest common multiple of 2 and of 3 is 6. So I'm multiplying both equations so that I get 6x. I could have done something very similar, by the way, for the y's. There's no reason why that wouldn't work. I could do exactly the same, but I just decided to go for the x's. So once I've got this set up, the process is exactly the same. I'm now going to look at the differences. So that top equation has an extra 5y, and then I'm going to compare my answers here. So I've got negative 21 and negative 16, and that top equation has therefore got an extra negative 5. And so 5y must be equal to negative 5. And so y is equal to negative 1. So I've got one value. I know that y is equal to negative 1. And I've got 4 different equations this time. But I only need to pick one of them. Any one of them will work. Usually it's easier to pick one of the original equations. So I have picked the second equation, 3x add 2y is equal to negative 8. And I've replaced my 2 tiles for y with negative 1 because I now know that y is negative 1. And that gives me a total of negative 2. And if I've got to make negative 8, then the x's then must make negative 6. So I know that 3x is equal to negative 6. So x must be equal to negative 2. So the only difference between this and what we were doing in the last lesson is that we're now having to multiply both equations to get the same number of x or the same number of y. So here's some for you to have a go at. It doesn't matter whether you make x the same or y the same. It will work either way, but you are going to have to multiply both equations. So could you pause the video here and have a go at answering these? Okay, so I am going to go through these with you now. So the first thing is, rather than draw out the original equations, I'm just going to think about how I could multiply my two equations. So let's say I went for the same number of x's. So I have got a 2 and a 5 as my coefficients. The lowest common multiple of 2 and 5 is 10. So I could multiply this top one by 5, and that would give me 10x add 15y, and that will give me 13 times 5, which is 65. And I can multiply this bottom one by 2, and that will give me 10x add 4y is equal to 10. So equally, I could have made my y's the same. So my coefficient of y's are 3 and 2. Lowest common multiple of 3 is, and 2 is 6. So I could multiply this top equation by 2, and that would give me 4x add 6y is equal to 26. And I could multiply this second equation then by 3, and that would give me 15x add 6y is equal to 50. So either of these two versions are going to give you a method for solving your equation. I'm going to stick to same x's though, so I'm going to get rid of this, and now I'm going to draw out my bars. So I have got 10x, which is a bit of a pain. Now, because these two are the same, rather than dividing all of these up, I'm going to save myself the bother, and I'm just going to write 10x in there. And then I've got 15y, and again, because I just don't want to have to draw out all of those, I'm just going to draw that, and I'm going to write 15y, and then that gives me, I'm going to draw it underneath here, 65. So then the other equation, I've got 10x, which is the same, and then I've got 4y. So I'm just going to draw out 4y, and that is equal to 10. So hopefully, I haven't drawn this in the best way because I haven't got them lined up, but hopefully what you can see, if you compare your 15y and 4y, you've got 11y more from this top equation, and then you compare your 65 and your 10, you've got 55 more for your top one. So 11y is equal to 55. And if I divide both sides by 11, y is going to be equal to 5. Okay, I'm going to get rid of this bar model on the bottom because now I need to do my substitution. So the substitution part is exactly as it was before. Now I'm going to go for my equation, one of my equations that hasn't been multiplied, because I'm going to have to do less drawing then. So I've got 2x, I'm going to take that top one, and then I've got 3y, and I know that each of my y's are 5, so I'm going to write in there 5, and I know that that is equal to 13. So this is giving me 15. Now, if I have to find a total of 13, well, the only way for that to give me a total of 13 is if this is negative 2. So that's telling me that 2x is equal to negative 2. So x is equal to negative 1. So if you did this by making your y's the same, you would have got exactly the same solution. You would have got y equals 5 and x equals negative 1. Okay, let's get rid of all of this, and then we'll try the second version. So, two options then. If I make my x's the same, I'm going to multiply this top one by 3. So I'm going to have 6x plus 15y is equal to 3. And I'm going to multiply my second equation by 2, which give me 6x add 4y is equal to 14. Equally, I could go for my y's being the same, and I would want to multiply my top equation by 2, which would give me 4x plus 10y is equal to 2. And I would want to multiply my bottom equation by 5, so that will give me 15x add 10y is equal to 35. So either of these will work. I'm going to go for x is the same again. So I'm going to draw this out now. And to save myself the bother of drawing out lots of boxes, I'm just going to draw 6x, add 15y, and that will give me 3. And then I will have 6x again, so that's the same length. Add 4y, and that will give me equals 14. Oops, don't know what that is. I'm going to have to draw a bar that probably isn't as long as it should be, but you get the idea, hopefully. So now I'm looking at the differences. Now, the difference here between the top one and the bottom one is this top one has got an extra 11y. But what it's equal to is less. So the difference between these two is negative 11. And that makes sense because if I've got more y's but it gives me an answer that's less, well, those y's must be negative. So 11y is equal to negative 11. And that means that y must be negative 1. So I'm going to rub off my bar model now. And I'm going to do my substitution. And I'm going to draw out my original equation, the first one there. So I'm going to draw 2x, and I've got 5y, but I know that each of those y's is negative 1. It's a very rough drawing, but it will do the job. And that is equal to 1. Positive 1. So these here, that's equal to negative 5. And if that is all going to be equal to positive 1, well, this bit here must be positive 6. And so each x then must be positive 3. So 2x is going to be positive 6, and x is going to be positive 3. Okay, so let's get rid of all of that. And then I will explain what your exercise is for today. So here is your exercise for today. There are 6 questions. Now you have got to solve these by drawing bar models. But before you draw the bar models, you've got to multiply both equations so that you've got either the same number of x's or the same number of y's. Once you've done that, you can draw out the bar models of your altered equations and then look for the differences. Okay, so pause the video and have a go at this exercise.